Hey, what's up, everybody? You know who it is. It's your boy Algebra coming to you live and direct from the studio, aka my dining room. Which of the following definite integrals represents the area of the shaded region? So, what we're looking at right now, for those of you keeping score at home, is the study guide that I gave you at the end of class earlier this week. For one of you guys, one of your classes that was today, the other one that was actually back on Tuesday. Just going through it, every single question, step by step, exactly what my thought process is. Here we go. First question, I started off at 0, ended up at 2. So what I need to start looking at is these pieces right here. It has to match 0 to 2. So I've got two options, the first one or the second one. If you don't put the dx at the end of the problem, it will not work. You need that dx to signify that you are going to use an antiderivative to unlock the value. Everything that you actually have inside of there, we can undo because it has the dx. If that part is missing, you get no solution. Thank you. Next. It says choose a correct statement given that 0 to 7 f of x is 8 and 1 to 7 is negative 3. So if I use those two things together, looking at the actual distance between 0 to 7 versus 1 to 7, there's some extra space in the first one. That means that the space between 0 to positive 1 is left unaccounted for in that second value. If I talk about the area of the shaded region, again, I don't know what this shape really looks like, but I told you that the second integral looks like this. The first one was the entire amount of space there. So what we're left with is that idea of find the area of the shaded region, which is always coming from a subtraction question. The area from 0 to positive 1 has to be 11. But then you say, why not C? Well, notice the integral is backwards there. It's the wrong direction. That would be the answer, would be negative 11. Order does matter. Question number 3 says from 2 to 5, you get 5. From 4 to 5, you get pi. Let's talk about these individual values. Well, the first one obviously has to be 0. That is a property. It's pretty obvious as well. You don't have any area if you never leave 5. If you go from 5 to 5, you would be subtracting those same values back away. No bueno. Letter B, negative pi. Why? Because I reversed the interval. By reversing the interval, I'm actually telling you that I am reversing the value as well. From 4 to 2, or excuse me, from 2 to 4, that amount of space, that is the difference between these two intervals. Your answer for this one, 5 minus pi. You're taking away the space that was from 4 to 5. Keep it moving. Number 4 says use the fundamental theorem of calculus to evaluate this. In your calculator, that would be FNINT. Inside the big box, you'll be putting square root of x. Little box off to the side, that will be an x. These two boxes, pretty obvious what you should be using is the 1 and the 4. You use your calculator for it, it's really quick and easy. But I would argue that this is absolutely a question that you should be able to do by hand still very quickly. Here's what I gave you. X to the 1/2. Add 1 to your power, put that on the denominator. X to the 3/2 over 3/2. Do a little bit of algebra magic. 2x to the 3/2 over 3. That's my antiderivative. That's what I'm going to plug in my 1 and my 4. Plug the 4 in first, subtract away the value from when I plug in the 1. I get a final answer, B, for big boy. Moving on, number 5. Fundamental theorem of calculus again, use it to evaluate the integral. This one requires you to think back and use some information from your unit circle that you originally learned back in either geometry, algebra 2 with trig, and hopefully you remember it up to this point in time. Fundamental theorem of calculus says do the antiderivative, plug in those values that you were given, 5 pi over 4 and pi over 2. All you have to do is go ahead and plug those in. The cosine of 5 pi over 4, you get, I'm going to go with 1 over radical 2. The reason why I'm choosing to do that instead of actually giving you a normal number there where we rationalize it is just because I see where it's coming from at the end of the answer. I see where it's coming from. That's the answer C. Those are pretty straightforward, really easy for number 4 and number 5. Number 6 actually requires you to do a little bit of thinking, and that thinking is how to deal with the absolute value. The absolute value says instead of going below 0, you have to stay above. And because of that, we don't ever want to have any negative portions of this area that we would be taken away. What we talked about back in the limits chapter is that if you have an absolute value, you turn it into a piecewise function. Same thing is going to take place now. We need to split this thing up. Let's go from -1 to 0 using negative x dx, and from 0 to +1 of positive x dx. So the question is, well, why am I doing that? The reason I'm doing that again is because on first side is a negative to force our values to be positive. We're reversing that thing. It was supposed to be a straight line, but we're taking that bottom part and flipping it up to the top. If I was talking about a parabola, I would be taking the entire middle section of that parabola from in between the two zeros and flipping it up so that it ends up having a hump in the middle as well as continuing up in the positive direction each time. That's really important that you understand that it is broken at those zeros of the function. If this interior of the absolute value said x minus 4, we would break our integral at 4. If we had x squared minus 9, I would have 2 breaks. I would end up with 3 separate integrals, both of them broken with that middle section being from -3 to +3. Fundamental theorem of calculus says you're still going to do your antiderivatives. You're still going to subtract those values once you plug them in, but you had to break it apart first to deal with the absolute value. Final answer, B. This next question, number 7, is the one that has caused the most struggle in our conversations, and I'm going to explain it one more time. The basic idea is this. This derivative is going to say, once you get your answer from the fundamental theorem of calculus, do the derivative of it. So in this particular question, we're telling you to evaluate the antiderivative of something that you don't know how to do. Since you don't know how to do it, but you do recognize that the integral and the prime are going to cancel each other out, it's going to be okay. All you're going to do is plug in an x value. Now the question is, why is the answer B instead of A though? The answer is B because of where your interval is broken at. It's where it is defined. With that x being the second value in the fundamental theorem of calculus, you would have been doing something that looks like this. Again, this reverts you right back to the original function. But why doesn't this matter? Well, this one doesn't matter, and I don't have to plug in a 1 because since it's an actual value, since you have evaluated it and gotten nothing but radical 2, well, there's no derivative for that. There's no derivative for a constant. That's why it ends up being only an x left over. It's only the second piece that's left. And in this particular situation, because it's the second one, it has to carry that minus with it. Be aware, if I do the same question and the derivative involves a chain rule, so it's not just x, maybe it's x squared, you would need to do that chain rule with it. Number 8 says find an expression equivalent to this. You don't know how to deal with this yet. That's way down the road. That's like months ahead of where we are right now. So don't. Leave it the way that it is. The second part of this tells you that I pulled out the 7 because I'm allowed to. That's like a scalar multiplier. That's what we call that bad boy. The 7 pulled out, there's still a 2 that's attached to the G. Answer C. Number 9, one of my favorite questions on here, it actually asks you to do something pretty simple. Break it apart. Start off by making it look like this. Doing this first step is actually really important because you already know the value for part of this. Well, you know what? Let's do one extra step even better. Let's take this 2 and move it out to the front so it's right there instead. By doing that, you actually have a value that will take this entire place. It's supposed to be 5. Now we're sitting at 2 times 5 times the integral from 4 to 7 with 4 inside. You could do an antiderivative on this and plug in the values of 4 and 7, but I think it's more important that you recognize the fact that this is a flat line and a rectangle. That's the only thing that it creates. It's the only possibility in this situation. Since it's flat, a Riemann sum would give you an exact value instead of an approximation. Make that rectangle. You know the width has to be 3 because of 7 minus 4. The height is 4. 10 plus 12. Final answer, 22. Woo-hoo! Number 10, easy. Not wasting your time on this video looking at number 10. Number 11, same situation we talked about before. Break your integral up so that you have, instead of negative 2 to 1, you need to stop at 0 the first time. This is going to be a negative x cubed. Start again at 0, end at positive 1, using a positive x cubed. The negative came first because it was the side that would be below 0. You know that graph is one of the originals that you had to remember. Looking at number 12, what's the antiderivative of secant squared? Tangent. What's the derivative of tangent? Secant squared. Remember, that second part, because it's just a value of x, since it doesn't have an x, the derivative of that would just be 0. Cancels back out. Number 13, again, I'm not going to give you questions like 12 and 13, like I said during class, but it's really the same thing. But this is the example where you end up plugging in that first value, log of x cubed, and you have to recognize that there is a chain rule involved with this. We don't have to worry about the one that has the part that has the 5, but we definitely need to deal with this extra chain rule. Another extra step that the AP would like for you to do is take this 3, move it down to the front, and then distribute it so that your final answer, best answer on this particular question, that we have log of x times 9x squared. Number 14, super important type of question. This is talking about accumulation. Accumulation, just like when snow falls, there might already be something on the ground, and so if we're going to accumulate, we need to account for that initial condition. You hear the crinkling in the background right now. That's my wife. She's telling me, saying, hurry up, come back, hang out with me. Her and the baby waiting on me, so let's speed this thing up. Population that increases at this particular rate. As soon as you saw rate, you knew that meant it had to be the derivative. That means an antiderivative is going to help us out. It says find the insect population after 2 days. Well, 0 right now. We're going to 2. What this tells you right now, this integral is going to give you how much has accumulated onto this function as it currently exists.